In the set operations, we have started the operation discussion, and in that we have already seen the union part. Now we'll see the intersection part. Intersection means what? Intersection actually is shown by the sign, which is actually the reverse of the union. And this intersection means anything which is common to both the set, both of the set. The common means if you say A intersection B, that means this X should belong to A and also it should belong to B simultaneously. So X intersection Y or A intersection B means those elements which are present in both these sets. For example, let us take this A as 1 to 10 and B as 2, 3, 5, 7. What you are going to do is you just have to find those elements which are common to A as well as B. So 2, then 3, then 5, and then 7. So these are the only numbers which are common to A and B. So A intersection B will give you answer as B. So A intersection B is 2, 3, 5, 7. And there is one more thing to note in this example, that when we intersect A with B, you get B. Why? Because B is a proper subset of A. B is actually the proper subset of A. So A intersection B, when B is a proper subset of A, will give you B only. The intersection, again, let us see via the Venn diagram. If this is your set A, this is another set B, the common part or the values elements which are common to A and B, these are the values which will come in the intersection. So intersection B will give you A and B, those elements which are exactly in A and also in B. But if you have two sets which are disjoint, that means they don't have any element common. So we say that A intersection B is nothing. So how do we represent nothing or null or empty? That is by our phi sign. In this set, A, if we take an example, 2, 4, 6 set, these are the even numbers, and B, 1, 3, 5, 7, these are the odd numbers. And if I want you to find out what are the numbers which are common, that is, I want you to find out the A intersection B, and you will come up with the solution that there is nothing common. So the answer will be phi. And why? Because these two sets are disjoint. They are not having any number between them or element between them common. So these are the operations on intersection. That is, if you intersect A with B or B with A, it doesn't matter because it is following the commutative law. Associative law means A intersection B, then you do it with C, or you do B intersection C and then do it with A. Associative law, no problem, both are same. And the empty and universal law is that if you intersect empty with A, because empty is nothing, so if you want to intersect this empty with A, it will be empty. And if you add or intersect union, this universal with the universal set with the A, then you will get A. Why? Because universal set, if this is universal set and this is your A, the intersection part is this only. So you will get A only. And if you want to intersect A with A, that will be idempotent law. If you have a set, say 1, 2, 3, and you want to intersect it with 1, 2, 3, so the element common will be 1, 2, 3 only. So you'll get the set again. There is one more important thing, which is the distributive law. So this intersection is distributive over union. That means that if this is A intersection B union C, this is exactly equal to A intersection B union A intersection C. So this is how a different scenario can be presented. That you have this B intersection C. So take B, C, shade all union C. B union C, you shade all the area. But if you want to find A intersection B, you will shade only the common portion. If you want to shade this A intersection C, you have to shade this common portion. Now, if you want to combine union and intersection, A intersection B union C, B union C is whole, this. But you want to intersect them, A with these whole. So only this shaded portion will come. This portion is going to come. And in this scenario, again, see, this is equal to this, as we just suggested. These two are equal because A intersection B union C is equal to A intersection B union A intersection C. So if you combine these two, you'll get this area only. So difference of set, what is the difference of set? Difference of set means take one set and subtract or remove all the elements which belong to another set. For example, if you have this 1, 2, 3, 4, 5, 6 and B is 2, 4, 6, 8. If you want to find A minus B, take all the elements which are present in B and just remove from A. Remove 2, remove 4 and 6. So what will be remaining? The remaining elements will be 1, 3, 5. So A minus B will be 1, 3, 5. What about B minus A? Pick up those elements from A and remove those elements which are common. So 2, 4, 6, 8. 2, remove 2. 4, yes, remove 4. 6, yes, it is there, so remove 6. And now 8 will not be removed. So actually B minus A will be your 8. So finally you see A minus B and B minus A are not equal. They are different. In the similar fashion, you take this example V and B and you can just find out by yourself that if you subtract V minus B and B minus V, they are not equal. So what we are doing is A minus B means take the intersection, means those values which are common, and remove it from A. That will give you the difference. So difference is any element X which will belong to A but it will not belong to B. So you have to remove all the elements of which are present in both from A. So this is the Venn diagram of A minus B, A intersection B and B minus A. Now complement of a set. What do we mean when we say complement? If this is a universal set and this is our set, complement means all the elements which are not in here, means in the universal set but not in this set. So complement means all the elements which does not belong to that set. Complement means those elements which are present in your universal set but they are not present in your set. So if I say some complement, I have to write it in this symbology, A dash. By A dash we say X would belong to your universal set but X will not belong to your set, right? So this is how this A complement can also be represented or being discussed as A complement is universal set minus A. Take a universal set, subtract your A or your set from that universal set. The answer would be actually your complement. Let us take an example. 1 to 10 we have universal set. We have A as 1, 3, 5, 7, 9. You just have to remove all the elements of U from A from U. So 1, 3, 5, 9. 1, 3, 5, 7, 9. Just subtracting. This subtraction will give you A complement. So all you will have is not having A. All this A complement is going to show you is those elements of U that are not in A. That is A complement. So this A complement, if you just take an example that you have your class, in your class 11th, there will be girls, there will be boys. If A is the set of all girls, what would you understand that A dash should be or A complement should be? Of course, in your class there will be girls, there will be boys if it is a co-education school. So A is the set of all girls. A dash would simply be all the boys because A dash means those which are not A. So all those which are not girls are actually boys. Now we want to find the result of A union B complement and A complement intersection B complement. Let us see. See, this is U. A is 2, 3, B is 3, 4, 5. Take complement of A. A complement is nothing but all the elements of U which are not from A. So just subtract 2, 3 from here. So you will get A dash as 1, 4, 5, 6. Again you subtract 3, 4, 5 from U. That will give you B complement. B complement will be just remove this 3, 4, 5. 3, 4, 5 remove 1, 2, 6. It will be remaining. Now let us find the intersection of these two. All the elements which are common to these are only 1 and 6. 1 and 6. Okay. So A complement intersection B complement will be 1, 6. Now A union B will be just combined A and B. So you will get 2, 3, 4, 5. And now you take A union B complement means all these should be removed from U. Remove all these 2, 3, 4, 5. So you'll be left only with 1 and 6, 1, 6. So A union B complement is A 1, 6, and this is exactly equal to this A complement intersection B complement. And as we see from this example, we can easily tell that A union B complement is equal to A complement intersection B complement. And this is a very important relationship. This is called the Demorgan's law. Okay, so the complement of the union of two set is the intersection of their complement, and the complement of the intersection of two set is actually the union of their complements. This is Demorgan's law, and this is how we represent it. We'll see that this is U, this is A, and this A complement is nothing but not A. So all the shaded area is your A complement. Let us see some properties of complements of set. First is, if you combine or you unite A and A complement, you will actually get the universal set, because A and A complement, they together comprise of the universal set. And again, A intersection A complement, because A and A complement, they don't have anything in common. So you'll get phi. What is phi? Phi is null. What about Demorgan's law? We have just seen Demorgan law and we have taken example also. So A union B complement is equal to A complement intersection B complement. Just see the reversal of the sign from union to intersection. In the similar manner, here also you see the reversal of sign from intersection to union. But when we open this bracket, the complement will be on both the sets. What about the law of double complementation? Let me tell you, these two properties are going to be used immensely in your further classes, further sections. So please understand them right now very carefully. The complement of the complement is actually the set again, means the set itself. So complement of A will give you A. Then the law of empty set and universal set, that is, if empty is complemented, you will get actually the universal set, because empty is nothing, and anything which is nothing is the whole thing. And if you want the complement of the universal set has everything. If you say anything other than universal set, that means nothing. So these are also very important, but these two needs to be seen very carefully, because we are going to use it very often in our discussion and equality and various operations. So we stop here now. We'll be taking one more sequence of this. Thank you so much. Take care of yourself.